Okay, here we go, number 3. Okay, number 3 is the opposite. Number 3 says, which of the following graphs, so which of the graphs below can represent the function whose slope is graphed first? So up here, they're now graphing a bunch of dots whose y-coordinates are all positive, and they're all equal to 1. And they want you to say, okay, therefore, which of the graphs below would be the f graph, where the f prime graph is showing us the slope of f? Hands up, who knows? There we go. So which graph below has to be the correct f, Brig?
A.
So if I look at A, 2 points if you knew that, nicely done. The slope of A, no matter anywhere, where it doesn't matter where I look on A, the slope of A is going to be a positive number. And in fact, the slope is always the same number because A is linear. The slope rise over run is 1 over 1. So up here, the slope being 1 everywhere matches perfectly with that. That's really all you had to do. Questions? You can see how Danica's chart works as well if you like. It's just a different way of doing it. You could say, okay, let's see here. I'm looking at my f prime graph, and I see an f prime graph that is, let's see, always positive. That would mean my f graph would have to always be increasing. Well, that would have right away eliminated b. B is increasing and then decreasing. It would have eliminated d, because d is constant, so neither of those could work. A and b would still be plausible at this point, but you could then go on and say, oh, wait a minute, the concavity of f prime is not increasing or decreasing. F prime is constant. That means f cannot be concave up or concave down. So that would have eliminated c, since c is always concave down. That would just be a different way of analyzing the problem. So, questions? Okay, cool. Let's keep going. Stop that.